Hello students, let's do exponents. Exercise 2b. Exercise 2b is on page number 33. We are with question 5. Simplify. Question 1. X raised to the power of a plus b. The whole thing is raised to the power of a minus b into. This dot means into x raised to the power of b plus c. The whole thing raised to the power of b minus c into x to the power of c plus a. The whole thing is raised to the power of c minus a. Now, the first thing that we are going to do here is we're going to apply the power law. That means we can multiply the powers. So let's do that. So let's start by writing x raised to the power of a plus b. This is the power already given and this is multiplied by a minus b into, remember the dot stands for multiplication, x raised to the power of b plus c into b minus c into the last one, x raised to the power of c plus a into c minus a. Okay, now if we look carefully, can we see this? A plus b, a minus b, b plus c, b minus c, c plus a, c minus a. So one is addition, subtraction, similarly here. Now we have learned algebraic identities where it says if you have the sum and the difference and you multiply both, you can get it this way, a square minus b square. So this is a formula that we should know by heart. A plus b into a minus b is equal to a square minus b square. So this is that same order, a plus b into a minus b. So this is going to be a square minus b square. So let's write that. So now x is raised to the power of a square minus b square. So you don't have to do the long multiplication to get to this answer. Into, now here also you can see b plus c and b minus c. That means that is equal to b square minus c square. So b square minus c square. So when you apply the formula, you can do this fast without wasting time on the long multiplication. Now here, next one is into x raised to the power of c plus a into c minus a, which is c square minus a square. So what have we done? We have applied algebraic identities, this formula, and we have got this step. Now what can we do? Can you see that all the bases are the same here? It's all x here, and it is multiplication. So when the base is the same and it is multiplication, we can add the powers. So let's add up all the powers. So this becomes x raised to the power of a square minus b square plus b square minus c square plus c square minus a square. So now we have it all. Let's look for the like terms. Now here we have a square and minus a square. So a square minus a square is 0. So this will get cancelled. This and this will get cancelled. Now let's look at the b. Minus b plus b. Minus b square plus b square will get cancelled. One is minus, one plus, so they get cancelled. So here it is minus c square plus c square. They also get cancelled. So what do we have left? It's all 0, isn't it? So x raised to the power of 0. And we have also learned anything raised to the power of 0 is equal to 1. So what is our answer here? Our answer here is 1. This is our final answer. Question 6. Simplify. So here in the first one, here you can see root 5 and you can see all these inside here, isn't it? And divided by x cube by y cube. Now don't get confused when you see a root like this. Now suppose you have just root x. Okay, and if you have to remove the root, we write it as x to the power of 1 by 2 because this is simply a square root. So when you have a symbol like this, it's simply a square root. Square means 2. So when you remove the square root, you write x to the power of 1 by 2. Now suppose you have root 3. Suppose you have root 3, then we write x raised to the power of 1 by 3. Now here what do we have? We have root 5, isn't it? So if we have root 5, x and root 5, if we have to remove that, we say x to the power of 1 by 5. So here, this whole thing is raised to the power of 1 by 5 when we remove this root sign, root 5. So in that case, let's write that. So let's write all these inside. That is x raised to the power of 20 into y raised to the power of minus 10 into z raised to the power of 5. We are removing the root sign, so it becomes raised to the power of 1 by 5 because it is root 5. Then the rest remains the same, divided by x to the power of 3 by y to the power of 3. So now we're going to use the power law. So we're going to multiply this power with this power. So each one inside we're going to multiply it with 1 by 5. So x raised to the power of 20 into 1 by 5 into, now y is already raised to the power of minus 10 into 1 by 5. Again, z is raised to the power of 5 into 1 by 5. So what have we done here? We have multiplied each power with 1 by 5. That's what we've done here. Now the rest of it, we write it as it is. That is divided by x to the power of 3 by y to the power of 3. So now here, just look at each of these. We can cancel. So let's see what we can cancel in the powers. 5 ones are 5, 5 fours are 20. Here 5 ones are 5, 5 twos are 10. Here 5 and 5 get cancelled. So now let's see what is left in all these and write it as it is. So this is x raised to the power of 4 into 1 is 4 into y raised to the power of minus 2 into 1 is minus 2 into z raised to the power of 1 divided by x to the power of 3 by y to the power of 3. So now if we have to put this in the form of division, since it shows division here, if we have to put this thing divided by this, how do we write it? We write it as x to the power of 4, y to the power of minus 2 as it is, z divided by, now if we write divided now, divided by x to the power of 3 by y to the power of 3. So you can see that now here for division we have a fraction. So now we can turn this to multiplication. How does that happen? Now this becomes x to the power of 4, y to the power of minus 2, z into, write the reciprocal. So y to the power of 3 and here we have divided by x to the power of 3. Now our division becomes easier. Now let's take only x. X to the power of 4 divided by x to the power of 3 makes it x to the power of 4 minus 3 because in division we subtract the powers. Then let's look at y. So here we have y to the power of 2 into y to the power of 3, which is addition, minus 2 plus 3, and then we have z by itself. So now let's simplify this. X to the power of, now here we have 4 minus 3, which is 1. So x to the power of 1 is x itself. Then y, let's see. Here we have minus 2 plus 3. So here signs are different. So we put the sign of the bigger number and subtract. So 3 minus 2 is 1. Y raised to the power is 1 itself. And then we write z. So here finally, what do we have our answer as? Simply x, y, z. So this is our answer to this question. Now do every step very carefully. Question 2. Here we have this whole fraction which is already raised to the powers here inside, which is raised to a negative power, minus 3 by 4. So we can continue like this itself and at the end change our powers to positive, or right at the beginning we can change this to a positive power by writing the reciprocal. So let's do it that way. So when we write the reciprocal, the 81b to the power of 4 comes to the numerator, and here we have in the denominator 256 a to the power of 16. Now this whole thing is now raised to the power of 3 by 4. So now the power has become positive. Now let's write 81 raised to the power of 3 by 4 into b to the power of 4, which is also raised to the power of 3 by 4. Remember, each one inside is raised to the power. So here we have 256 raised to the power of 3 by 4 into a to the power of 16, which is raised to the power of 3 by 4. So here 81 raised to the power of 3 by 4. This is what we have here. Let's get the prime factors of 81. So 81 prime factors will be 3. 3 twos are 6. So what is left is 2. 21. 3 sevens are 21. 3 nines are 27. 3 threes are 9. And 3 ones are 3. That means instead of 81, we can write 3 raised to the power of 4. So here let's write 3 raised to the power of 4. The whole thing is raised to the power of 3 by 4. So always get a power which is close to the denominator here in this power. Okay. So next one is b to the power of 4 into 3 by 4. We are using the power law. Now this whole thing is divided by 256 raised to the power of 3 by 4. Let's get all the prime factors of 256. So 256 is divided by 2. 2 ones are 2, 2 twos are 4, there's 1 left. 2 eights are 16. Then we have 2 sixes are 12, 2 fours are 8. Then we have 2 threes are 6, 2 twos are 4. 2 into 16 is 32. 2 into 8 is 16. 2 fours are 8 and 2 twos are 4. Finally, 2 ones are 2. Now here we have 1, we can count and see 1, 2, 3, 4, 5, 6, 7, 8. That means 256 can be written as 2 raised to the power of 8. Now we can simplify this further. We can write it as 2 raised to the power of 8 here, or we can simplify this further because a power is 4 here, 3 by 4 in the fraction. Can we get a power that is equal to 4? This is just to make our work easier. So we have all 2's here. Let's see if we can make them into 4. So this is 2 2's are 4. Then this is 2 2's are 4. Again we have 2 2's are 4. And then we have 2 2's are 4. So how many 4's do we have? 4. So 4 raised to the power of 4. So 256 can also be written as 4 raised to the power of 4. Now that's easier to use. So we're going to use that. So instead of 256, we're going to write 4 raised to the power of 4. And this whole thing is raised to the power of 3 by 4. Into, we have a here raised to the power of 16 into 3 by 4. So in the next step, we can use the power law and write 3 raised to the power of 4 into 3 by 4. And b, now we can cancel this 4 and this 4. So b is simply raised to the power of 3. In the denominator, we can say 4 raised to the power of 4 into 3 by 4 into a, and here we can cancel. 4 ones are 4, 4 fours are 16, 4 threes are 12. Here, when we continue, we can cancel this 4 and this 4. So that becomes 3 raised to the power of 3 into b raised to the power of 3. In the denominator, cancel the 4 and 4. So that becomes 4 raised to the power of 3 into a raised to the power of 12. Now 3 raised to the power of 3 is 3 threes are 9, 9 threes are 27, b to the power of 3. Now 4 raised to the power of 3 is 4, 4s are 16, 16 fours are 64. So this is 64 raised to the power into a to the power of 12. So what is our final answer? 27b to the power of 3 by 64 a to the power of 12. Question 7. Simplify and express as positive indices. A final answer should have a positive power. So here we're going to start off with this first. So this is going to be a to the power of minus 2. This whole thing is raised to the power of minus 2 into b to the power of minus 2. Dot stands for into a to the power of minus 3 into b to the power of minus 3. So here for this one, we're going to use the power law, which says a to the power of minus 2 into minus 2. Then the rest remain as it is. So b to the power of minus 2 into a to the power of minus 3 into b to the power of minus 3. So this is going to be a to the power of minus 2 into minus 2. Minus into minus is plus. 2 into 2 is 4. So this is a to the power of 4 into b to the power of minus 2 into a to the power of minus 3 into b to the power of minus 3. Now, if base is the same, we can add the powers. So here we have a and a, the base is the same, so we can add up the powers. So that will be a to the power of 4 plus minus 3. Similarly, we can do that with b also into b to the power of minus 2 plus minus 3. So this becomes a to the power of 4 minus 3 into b to the power of minus 2 minus 3. So this is a to the power of 4 minus 3 is 1 into b to the power of minus 2 minus 3 is minus 5. That is, this can be written as a Since a to the power of 1 is simply a and b to the power of minus 5, our question says write as positive indices, positive. So our power has to become positive. So a is written as it is. To make the power positive, we write the reciprocal. So b by 1 becomes 1 by b, or we put b down and write the positive power. So a by b to the power of 5. So this will be our final answer, and this has a positive power. Question 2. Here also, as you can see, this whole thing is raised to the power of 4 and this whole thing is raised to the power of minus n. That means we can use the power law and multiply. So this will be x to the power of n into 4 into y to the power of minus m into 4 into x to the power of 3 into minus n into y to the power of minus 2 into minus n. So this is x to the power of n into 4 is 4n into y to the power of minus m into 4 is minus 4m into, here we can say x to the power of 3 into minus n is minus 3n into y to the power of minus 2 into minus n, minus into minus is plus, 2 into n is 2n. So now let's look at the base. If the base is the same, remember we can add the power. So let's take the x and we can add up the powers. So this will be x raised to the power of 4n minus 3n. Similarly, we can take the y's also into y raised to the power of minus 4m plus 2n. So this is now x raised to the power of 4n minus 3n is 1n. So simply n into y raised to the power of, now these are unlike variables. So we can't solve it. It will remain as it is. So this is going to be minus 4m plus 2n as it is. But here our question says we have to make this a positive index, isn't it? So the indices has to be positive. Now this is positive, so we'll write this as it is. X to the power of n into, now to make this positive, we just have to put this positive number in front. So that becomes y to the power of 2n minus 4m. So our final answer is this, x to the power of n into y to the power of 2n minus 4m. Question 3. So here we have this whole thing raised to a negative power again. So here either you can change it to a positive power by writing the reciprocal or continue like this itself. So let's try to continue like this itself. So I'm trying both ways for you to understand and pick up the easier method. So this will be 125 raised to the power of minus 1 by 3 into a, which is raised to the power of minus 3 is raised to the power of minus 1 by 3. Similarly, here this is going to be y raised to the power of 6. This whole thing is raised to the power of minus 1 by 3. So we're going to use the power law. So 125, we are going to find the prime factors. So 125 will be 5 2's are 10. So there's 2 left. 5 5's are 25. 5 5's are 25. And again 5 1's are 5. So 125 can be written as 5 to the power of 3. So let's write that instead of 125. So 5 to the power of 3 is now raised to the power of minus 1 by 3 into, now here let's use the power law. That is minus 3 into minus 1 by 3. Now here also let's use the power law, y raised to the power of 6 into minus 1 by 3. So here let's continue. This becomes 5 to the power of 3 into minus 1 by 3. So this gets cancelled. The 3 and 3 get cancelled. Now on the next variable is a. So here also 3 and 3 get cancelled and the minus and minus into minus is plus. So that's simply a raised to the power of 1. Now in the denominator, what do we have? Here we can cancel 3 and 6. 3 2's are 6. So we have y raised to the power of 2 into minus 1 is minus 2. So what do we have here? 5 raised to the power of minus 1 into a raised to the power of 1 is a, and here we have y raised to the power of minus 2. Now we have to write this as a positive index. That's what our question says. Write your answer as positive indices. Now, if I have to change 5 raised to the power of minus 1, if I have to change this minus 1 to positive, I have to write the reciprocal. So let me write that. So that becomes 1 by 5 raised to the power of 1. Now the power is positive into a. Now here we have y raised to the power of minus 2. If I have to write this as a positive sign, positive power, I have to write the reciprocal. So y from the denominator will go to the numerator. So that becomes into y to the power of 2. The power is now positive. So let me multiply everything together. Now 1 into a to the power of y square is a y square. In the denominator, 5 raised to the power of 1 is simply 5. So our final answer is this, a y square by 5. Question 4. Here also we have a negative power. So you can either write it as a positive power by writing the reciprocal or continue like this. So the previous one we left it as it is. This one, let's change the sign and make it a positive power by writing the reciprocal. So this becomes 243 y to the power of minus 5 by 32 x to the power of minus 5. So I've written the reciprocal. So now that I've written the reciprocal, my power will become positive. So that becomes 1 by 5. So now this is 243 raised to the power of 1 by 5 into y, which is raised to the power of minus 5, is also raised to the power of 1 by 5. Similarly here, 32 is raised to the power of 1 by 5 into x, which is raised to the minus 5, is raised to the power of 1 by 5. Now let's find the prime factors of 243. 243, let's divide it by 3. 3 eighths are 24, 3 ones are 3. Then here we have 3 twos are 6, 21, 3 sevens are 21. Now 3 nines are 27, 3 threes are 9, and 3 ones are 3. So 243 can be written as 3 raised to the power of 5. So let's write that. So 3 raised to the power of 5, this whole thing is raised to the power of 1 by 5 into, let's use the power law here, y to the power of minus 5 into 1 by 5. In the denominator, we have 32. Now 32, let's find the prime factors. Divided by 2. 2 16s are 32. 2 8s are 16. 2 4s are 8. 2 2s are 4. And 2 1s are 2. So 32 can be written as 2 raised to the power of 5. So let's write that here. So this is 2 raised to the power of 5, which is once again raised to the power of 1 by 5 into x to the power of, let's use the power law, minus 5 into 1 by 5. So this will be 3 raised to the power of 5 into 1 by 5 using the power law into y raised to the power of minus 1 by 2 raised to the power of 5 into 1 by 5 using the power law into x to the power of minus 1. Now here we can cancel 5 and 5. Here also we can cancel 5 and 5. So here what do we have now? We have 3 raised to the power of 1 into y raised to the power of minus 1 by 2 raised to the power of 1 into x to the power of minus 1. Now, since we have to make it all into the positive indices, we're going to go carefully with each one. Now, this is 3 raised to the power of 1, which we can write as 3 itself into, now the next one is y raised to the power of minus 1. Now, how do we make this a positive power? By writing the reciprocal. So, y to the power of minus 1 will now become 1 by y. 1 by y raised to the power of 1. Then we have 2 to the power of 1, which is 2 itself. So, by 2 we can write it here. By 2, then let's look at x. X is raised to the power of minus 1. To make this a positive power, we have to write the reciprocal of this. That means x will now go to the numerator. So this becomes into x to the power of 1. So let's write it all together here now. So here we have 3 into 1 into x. So that is 3 into x to the power of 1, or 3 into x, which is 3x. And in the denominator, we have 2 into y. That is 2y. So what is the final answer? 3x by 2y. Question 5. This whole thing is raised to the power of 1 by 2 and this is raised to the power of 1 by 3. So let's start working this out. So this will be a to the power of minus 2. This whole thing is now raised to the power of 1 by 2 into b raised to the power of 1 by 2. Now the other bracket, a raised to the power of 1 by 3 into b raised to the power of minus 3. This whole thing raised to the power of 1 by 3. So using the power law, this will be a to the power of minus 2 into 1 by 2. This will be b to the power of 1 by 2 into a to the power of 1 by 3 into b to the power of minus 3 into 1 by 3. Now here what can we cancel? We can cancel 2 and 2 and 3 and 3. So what is left here is a to the power of 1, which is a, into b to the power of 1 by 2 into a to the power of 1 by 3 into b to the power of minus 1. So that is minus 1 itself, b to the power of minus 1. Now here also a to the power of minus 1. So let me read this part again. A to the power of minus 1 into b to the power of 1 by 2 into a to the power of 1 by 3 and b to the power of minus 1. Now let's take the like variables. So here we have a to the power of minus 1 and a to the power of 1 by 3. So we have to add that a to the power of minus 1 plus 1 by 3 into, similarly with b, we have b to the power of 1 by 2 plus minus 1. So now this addition, minus 1 plus 1 by 3, let's do it here. So minus 1 plus 1 by 3. So this is addition of fractions. So the LCM is 3. So 1 into 3. So this also minus 1 into 3 is minus 3 plus 3 into 1 and 1 into 1 is 1. So now this will be minus 3 plus 1 is minus 2 by 3. So this becomes a to the power of minus 2 by 3 into, now here let's see, we have to work out this one, that is 1 by 2 minus 1. So this will be minus 1 by 1. Again find the LCM, this is 2. So 2 into 1 is 2. So 1 into 1 is 1 minus 1 into 2. So 1 into 2 is 2. 1 minus 2 is minus 1. So this is minus 1 by 2. So this will be b to the power of minus 1 by 2. Now to make this positive, we have to write the reciprocal. So a by 1, this will be a by 1 will now become 1 by a. So this is 1 by a to the power of 2 by 3. The power has now become positive into again 1 by b. The power has become positive 1 by 2. So this is 1 by a to the power of 2 by 3 into b to the power of 1 by 2. So this is our final answer. Question 6, we have this raised to the power of m minus n, this to the power of n minus l, and this raised to the power of l minus m. So now let's start working this out. So this will be x to the power of m minus n into y to the power of m minus n into, again y to the power of n minus l into z to the power of n minus l into z to the power of l minus m into x to the power of l minus m. Now let's take the variables with the same basis, that is we have x here and x here. So let's take that. So that becomes x to the power of m minus n, and we can add the bases, add the powers, plus l minus m. So when base is the same and it's multiplication, we can add the powers. Now let's take y. We have y here and y here. So that will be into y to the power of m minus n plus n minus l. Then we have z. Z is here and here. So that will be into z to the power of n minus l plus l minus m. So now we can cancel. We have m and minus m. So these two get cancelled. Let's go to the y. Y we have minus n and plus n, that will get cancelled. Let's go to the z. Minus l and plus l get cancelled. So now what do we have? We have x to the power of minus n plus l, then into y to the power of m minus l into z to the power of n minus m. Now look at the first one. We have to make it positive, isn't it? So we're going to write L first. So this will be x to the power of L minus n into y to the power of m minus L and into z to the power of n minus m. So this is our final answer. So we will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.